Today we're going to have a look at writing a little subroutine that can check for overflow. Overflow is one of those things that can happen often, so it'd be good to have a subroutine that you can just call any time to check your code for overflow. So what we've got here is a little file and it's just doing one addition, nothing too exciting, but it's got two numbers that when you add them together they'll certainly cause overflow. So what we want to do is write a little subroutine that we can call in this file and check for overflow and maybe throw an exception or print a message if overflow has occurred. Now, in one of the previous videos I went over how to detect overflow, writing out in Mars and whatnot. I'm going to do the same thing again here, but we're going to make it in a format that is usable for subroutine conventions. Because you can see here, this is the previous code I used, but I'm using a lot of saved registers and it's a bit of a mess in general. So I want something that is reusable and that can be called on from different files maybe and just used to check for overflow for a single sum. So first things first, I've got an assumption up here at the top, which is that the value A is placed in A1, the value B is placed in A2, and the sum of these two is placed in A0. So we're going to assume that's where they are to start with. First things first, I should give this subroutine a name. I'm going to call it check over. I'm just using a label to do that. And back in here, what I should do is I should have jump and link check over. And that'll jump to the other file. If we include it, it'll jump to the subroutine, execute that code, and then return to this place in this file's code, because that's what the jump and link construction does. It'll set the return address register equal to the place in the program that was here, and then it'll come back to that point. So now in here we just need to structure this in a reasonable way to test for overflow. So I'm going to do the usual XOR, and let's put it in T0, and we're going to check A1 and A2. And this will just check to see that they both have the same sign, so it'll be greater than 0 if same sign. I'm just going to do this quickly since we've already gone over this in a couple of previous videos. And then I want to say set greater than, and let's put that in T0 because we won't need to use T0 again. We'll need T0 and we'll need 0. So if T0 is greater than 0, then we'll raise a 1 flag. Otherwise, we'll just leave it as 0. So that's fine. Next, I want to see that the sign in the result, is it different from the sign in the first two? So if the first two have the same sign, we add them together and get a different sign, that's overflow. So that's what I want to check for. So let's put it in T1. And I want to check A0. And it doesn't matter which of the signs that I check, because if I check them, I've checked them both up here, and if they're the same, we'll succeed later on. So I only need to check against one. Again, you can find a more detailed overview of this in one of the previous overflow videos, but I'm just doing this quickly. So check sign is different, and if their sign is different, this will be less than 0. So I want to say set less than, and let's just store it in T1, and it's going to be the value in T1, and I want to see if it's less than 0. So yeah, just leave that. So if there's different signs, this will check for that because we've XOR'd the two values. So if it's less than 0, that means that the two bits that we've checked had different signs, and therefore something is going weird. And then all I want to do is AND these two values together. So this is going to be, let's put this in T, I suppose it doesn't really matter where we put it, let's put it in T2. So I'm going to put T1 and T0. And that's just checking both conditions to see if they hold. Now that that's done, I want to say branch if not equal, and T2 should be equal to, if it's equal to 0, then we just want to go to, oh no, sorry, if it's not equal, we want to go to the overflow section. So I'm testing to see if overflow has occurred, and if it's not equal to 0, the value in T2, that's the AND in T2. So if that's not equal to 0, then overflow has occurred. So we want to say has overflow occurred, and I'll have to go to another section which I'll call overflow. So let's put that there. Otherwise, I want to jump to the end. So you'll notice I've not used any of the saved registers. We're overwriting, or we're using A0 and A1, but we're not overwriting those values. Remember that subroutine is not obliged to save the values in A1, A2, A3 or whatever, but we should either put something in V0 or we should cause this program to crash. So what I'm going to do is I'm going to put break, and that just throws an error. We're not going to go too deep into error messages at the moment, but you can give this a code. So let's just say if I want to give this an error message, I could just say 7, and that'll give me error code 7. Otherwise, I want to jump to the end, and the end is just jump register. So this will jump the register back to RA, and that will take me back to the previous file where we actually did the sum. So that's everything I need in here. We're testing for overflow. We're throwing an exception if overflow has occurred, and that'll just crash the program. I'll just end it. Otherwise, we jump back to wherever we were in memory previously, which will be in here. Now, if I want to call this from a different file, I can't just write it like this. I need to do .include. And we're going to call it ovf1.asm. And this will include the file. Now, one thing you have to be wary of is if I assemble this, hopefully don't get any errors, is you can see that the code is literally just inserted at the bottom here. This is just our whole file's worth of information. So when we insert it, we need to actually load the immediate value of 10 into v0 and do a syscall. And this will stop it from this will end the program before it gets down to that text at the bottom here. Now, it would have been at the bottom anyway in this instance, but you need to be wary of this in future examples. For example, if you were counting the length of the array and you use a similar technique here to import the count length feature, you would always get down to the bottom and then just go through another loop just because you've left that code at the bottom there. So you need to be careful not to let that happen by ending your code appropriately. So let's assemble this and run. So there we go. Runtime exception, that's our break instruction, it's executed, break 7 is executed, and instruction code executed, code equals 7. So that means we have detected overflow and we have crashed out. Now I can give this these two different values. I can give this 0, and let's say we give this 0, some large number, and we compile this and run it. That shouldn't give us overflow, and we'll just finish running. So this is one example of when you might want to write a subroutine and why it would be useful. It's particularly when you have things you need to repeat a lot, so we'll probably wind up writing some subroutines to count the length of strings, that sort of thing, just so that we have something that we can reuse whenever we need to for common tasks. This is just one example though. I hope you found this useful. If you have any questions about anything I've covered here today, please do let me know. Thanks.